We previously examined the merits of software-defined networking and how that helps simplify the management and configuration of our infrastructure. Cisco has taken that one step further with something they call software-defined access, or SDaccess. Let's run down a few advantages provided by software-defined access, starting with the features of Cisco DNA Center. Cisco DNA Center is a key piece of the SDaccess solution and acts as a central point of management. And that central point is able to automate the deployment and the configuration of network devices. With SDaccess and Cisco DNA Center, network device configuration becomes automated. Whether you're deploying one or multiple new devices in the network, DNA Center works as a central hub of control, which allows for super fast deployments. Policy enforcement is another important improvement offered by SDaccess. Rather than relying on traditional access control lists, SDaccess uses something called Security Group Access Control Lists, or SGACLs. These can be thought of as a group-based policy, and they're much more scalable. If you think about traditional ACLs, those rely on IP addresses and subnets, which can be complicated to maintain or to scale for a larger network. SGACLs used by SDaccess, those overcome this limitation through group policies that are based on client identity rather than IP addresses. So we don't have to worry about the scalability. Using those policies make it much easier to scale. Going hand in hand with this is the ability to securely segment the network very simply. Since SDaccess sees the entire infrastructure, both wired and wireless, as a single network fabric, it's very easy to segment the network without the need for various firewalls or other complicated access control lists. And network virtualization is also a big plus for SDaccess. This allows our single physical infrastructure to be separated into multiple virtual networks. Each of these virtual networks can have their own set of access policies that are created and enforced through SDaccess. We can break down the SDaccess solution into two main components: Cisco DNA Center, which we've already mentioned, that provides automation and orchestration throughout the network, and something called Campus Fabric. Recall that we discussed underlay and overlay networks in a previous video. The underlay network is our physical infrastructure, and Campus Fabric is simply another example of an overlay network. Specifically, it's a Cisco validated overlay. The Campus Fabric solution ideally will manage the network through use of Cisco's DNA Center. This can also be managed via CLI or API through the netconf protocol and Yang modeling language. We'll discuss netconf and Yang more in depth later in this series, but for now, just know that these are options used to operate the network infrastructure in a campus fabric. The reason that a campus fabric was developed is to overcome traditional campus network issues, things like spanning tree problems and layer 2 forwarding. And it's also an improvement over architectures such as 3-tier or spine and leaf. So campus fabric can really simply be thought of as a next generation campus network where management and configuration is simplified and centralized into a single point. Here we can see a graphical example of what this looks like. We see an actual physical underlay network and the Campus Fabric overlay network. The Campus Fabric is what provides our network with segmentation and security features through those policy-based security groups that we mentioned earlier. Also know that the security provided here goes beyond traditional routing and switching security capabilities, because it's recommended that you leverage Cisco's Identity Services Engine to gather contextual user information for those security policies. So here we can see that even though our underlay network is a little more complicated and it has a few more intermediate devices, the overlay network simply sees that as a much smaller and simplified network. So that's just a really easy example of how that works. Now we've already The campus fabric overlay can be configured through CLI or API, or it can be fully automated through DNA Center, which is actually the recommended method. So while you can use a campus fabric solution and manually configure that through CLI or API, that is not considered to be SDaccess when you configure in that manner. SDaccess is specifically defined as being fully automated with DNA Center. If DNA Center is not being used, then you simply have a campus fabric solution. You do not have a software-defined access solution. So that's just some nomenclature that you should be aware of. So from here on out in this discussion, we're assuming that we're using both a campus fabric solution and DNA Center, which we'll generally refer to as SDaccess or the SDaccess fabric. You probably won't be surprised to learn that there are three planes of operation in the SDaccess fabric: the control plane, the data plane, and the policy plane. The policy plane is based on Cisco TrustSec, which will be covered in depth later in this series. TrustSec helps to create the security groupings that we mentioned earlier, so that policies can be based on identities rather than IP address schemes. The SDaccess control plane is based on the Locator ID Separation Protocol, or LISP for short. LISP is simply an addressing architecture developed by Cisco as a variation of node addressing. So rather than relying on a single numbered address identifier, such as an IP address, LISP creates two addresses for each node, one address for its identity and another for the location where it's found in the network. So LISP is a way to simplify traditional routing and to streamline our network. The SDaccess data plane leverages a tunneling technology called Virtual Extensible LAN, or VXLAN. This encapsulation is what creates the SDaccess overlay network. This is UDP-based communication, meaning that any IP-capable device has the ability to forward the information. The VXLAN encapsulation allows for not only Layer 3 overlay networks, but also for creating separate virtual network instances where separate policies can be applied and enforced. So know that the control plane uses LISP data encapsulation, while the data plane uses VXLAN encapsulation. Both of these encapsulations will be examined closer later in this series. If we break down a typical topology structure visually, we'll see four distinct layers in SDaccess architecture. We can see that the physical layer is, of course, our actual infrastructure devices: routers, switches, our wireless infrastructure, a DNA Center appliance, and a Cisco Identity Services Engine appliance as well. In the network layer, we see our underlay and overlay networks. The underlay network includes the settings and protocols used in the physical infrastructure for transporting data packets, while the overlay network is a virtual network that forms a fabric of its own. As we saw earlier in our example topology, this overlay strips out some of the limitations and complexities of the network and makes a more simplified fabric. The tunneling is performed using VXLAN encapsulation to build that fabric. And then we have the controller layer, which consists of Cisco DNA Center and Cisco Identity Services Engine appliances. We can break down Cisco's DNA Center into two main structures here, which are the Cisco Network Control Platform and Cisco Network Data Platform. Cisco NCP is used for automation and orchestration of the physical and network layers, while Cisco NDP is used to collect analytics and historical trends used by the management layer and by Cisco ISE. Cisco ISE, of course, is for identity and security services and is the piece that identifies and places users into those policy groups so that the policies can be enforced throughout the network fabric. Finally, we have the management layer, which is the Cisco DNA Center user interface. This is essentially a centralized dashboard that allows you to view and control your entire network through intent-based networking. The unique thing here is that Cisco DNA Center provides really simple GUI tools for management and deployment, which means that you don't necessarily have to know how to configure each individual network device in order to use this deployment method. Really unique. So now that we understand